Welcome back, guys. Today we are in 14.6 talking about trapezoids and kites. So let's first start by defining these words. So we have a trapezoid is a quadrilateral with exactly one pair of parallel sides, and those pairs of parallel sides we call bases, even though it's on the top. So you have to kind of break. In your brain, you're probably thinking base means bottom. Base does not always mean bottom. Here, our bases are the parallel sides, and the non-parallel sides are called the legs. So we have a leg here and a leg there. We've got base angles, and the base angles are pretty much all the angles, but it's the angles on the bases. We'll talk about the relationships of those later. And then an isosceles trapezoid, trapezoid with legs that are congruent. So again, these bases here, BC and AD, are parallel, but then we have base or legs that are congruent. So we've got our leg here is congruent and our leg here is congruent. All right, so when we look at our got it, which please make sure you've worked through the Pearson module to make it to here, our think question asks us, what do we know about the angles of an isosceles trapezoid? So here we have an isosceles trapezoid because I have these legs that are congruent. But if I look at this angle of 106, and I want to talk about how it relates to this unknown angle down here, well, let's just grab these sides, slide them on up. And because my sides are parallel, what I see when I shift this over is I actually end up with a straight angle. So since we know that a straight angle equals 180 degrees, this tells me that any two angles of my isosceles trapezoid that are consecutive, those are going to be a supplementary pair. So if they're the two angles of a leg, sorry, saying consecutive can get dicey because I can have these two base angles. Those would be consecutive, but they would not be supplementary. We'll talk about that in just a second. So any two angles of a single leg, because remember here my legs are QR and PS. So if these two are supplementary, let's figure out what angle Q is. So to find angle Q, I just set up my angle sums because I know they're supplementary, and I subtract 106 from both sides to find that Q is 74. Now, looking at P and S, I can come up here and grab my angle R again and use that to help me. If I spin it just like this, I can see that angle R is actually the same size as angle S, because if I have a trapezoid where I know my bases are parallel and it's isosceles where my legs are congruent to each other, because my legs are congruent, that means that my angles must also share angle pairs. So any two angles of a base are congruent. Any two angles of a leg are supplementary. So R and S will both be congruent. Q and P will both be congruent. So what I see is Q and P are both 74, R and S are both 106. So B is asking us in problem 1 if CDEF were not an isosceles trapezoid. So we've got CDEF right here. It is shown as an isosceles trapezoid. But if it were not, would angle C and angle D still be supplementary? Now, being that it's a trapezoid, we know that my bases have to be parallel. So I've got these parallel bases here. And even if EF got, let's say it got shorter, so that would move F this direction. So even if F came and it was almost right below E, C and D would still share the supplementary relationship because they are same side interior angles. These parallel lines will never not be parallel because it's a trapezoid. They have to be. So therefore, I always have that these angles would share that supplementary relationship. Pause the video to try to solve for all the unknown angles in 1 and 2 and come back just to verify your answer. So in number 1, I see that my base angles here, angle 1 and the angle marked 77 degrees, would have to be congruent. So 1 will be 77 degrees, and then angle 3 and angle 2 up here are also going to be congruent, and then angle 3 is going to be supplementary with 77 degrees because they are same side interior pair. So I see that 1 must be 77 and 2 and 3 must both be 103 degrees. Over in number 2, I see the same basic thing. 1 would have to be the same as our 49, and then 3 and our 49 degree angle would be supplementary. So I see that angles 2 and 3 would be 131 degrees, while angle 1 measures the same measure of 49 degrees. Please make sure you work through problem 2 because our got it here relates to problem 2. We want to talk about a fan like what we saw in problem 2, which ends up being a circle, but it's actually formed out of a lot of individual triangles, so it just looks like a circle, but doesn't quite meet all the specifications. So we say that in the middle there are 15 angles meeting at the middle. What are the measures of the base angles of the trapezoid in the second ring? All right, we've got a lot to discuss here. So what I see is since there are 15 angles in the center, to solve the top angle or the angle right inside the middle here, we're going to take the whole 360 degrees and divide it by the 15 angles that are in there. So for that, we get 24 degrees, so that would be the measure of the tip of my triangle here. Then moving down to the base of this, I know that it must be an isosceles triangle, so the base angles are going to be equal to each other. So I take the amount that's left over, 156 degrees, to make up the rest of my triangle and divide it by my two angles, which gives me 78 degrees. So both of these angles down here will be 78 degrees. We can color code that really quickly. Now, moving on, we're going to look at the top angles of the trapezoid. Well, those top angles must be supplementary with the 78, so those will both measure 102 degrees. And then, because my base angles must be supplementary with their corresponding other angle on the leg, I know that those will be supplementary also, so they will be 78 as well. And there's everything color-coded out for you. Try numbers 3 and 4 on your own, trying to solve for all of the unknown angles, and then come back when you are ready to verify your answer. I do not think I should need to walk through the supplementary pairs that let you solve. So in number 3, you have angle 1 measuring 105, same as angle X up here, and then angles 2 and 3 will both be the same at 75 degrees. In number 4, you get angle 3 being the same as your 60, and then angles 1 and 2 both being equal to 120. 57 is a new theorem for us. So 57 is telling me that in an isosceles trapezoid, so we know isosceles means that these legs have to be congruent as well as the bases being parallel, that my diagonals will be congruent to each other. So my diagonal BD and my diagonal AC will have the same lengths. So topic 13, we talked about mid-segments of triangles. Now we're going to talk about mid-segments of trapezoids. So in a trapezoid, we have a mid-segment here. So M is the midpoint of RT and N is the midpoint of AP, creating these congruent segments. And what I see is this creates two things that happen. My mid-segment MN is also parallel to the base, because if I went halfway up and halfway up, that'll still be parallel. And then its length is half of the sum of both of the bases. So it's essentially the average of the bases. So you could add up both bases, divide by 2, or multiply by 1/2, and you will get the length of that mid-segment. After you work through the Pearson module, go ahead and come back here, try the got it, and then play the video when you're ready to check your answer. So pause the video for now. Alright, so when we approach part A on this got it, we know that MN is the midpoint, so it's going to be half the sum of our bases. So I go ahead and write that out. I'm not even going to deal with the expression for MN yet. I'm just going to write out the work for half the sum of the bases. So I have my top base, my bottom base. I'm trying to add them together so I can only add the like terms. So I add the 10 and the negative 12, which gives me a negative 2. I still have the 8x. I then want to evaluate half of that. So I get negative 1 plus 4x. And now I will plug in for my MN actual expression. So I have this binomial now equal to this binomial. I use the algebra to solve. Here I added 1 on both sides and I subtracted 2x from both sides. So I got 12 equal to the 2x. And then from there I divide by the 2 to find that x is equal to 6. Now that I have my x value, I can plug it in and check for things. So the first thing I did, it wasn't really necessary, but I wanted to see how long was the base on the bottom. But when I do my math plugging in 6, I get that it's actually 52. And when I do my math to solve for the mid segment, I just plug in 6 for the x, and I get 2 times 6 plus 11, which is 12 plus 11, which is 23. Take a moment to think about B. How many mid-segments can a triangle have? How many mid-segments? So if I look at my triangle down here, and I want to just draw the first easiest mid-segment I can think of, Probably that, if assuming this is the middle of each side. But then I can also go from the middle of that side to the middle of this side, and from the middle of the bottom side up to the middle of my left side. Oh, try that one more time. Get a straight line this time. So we can actually draw 3 mid-segments on any triangle. Pause the video and do 5 and 6 on your own. I'm going to come back and quickly go through the work, so please do this on your own so you know you're able to. Alright, like I said, I'm going to quickly go through this. So, we know that EF, our mid-segment, is going to be equal to half the sum of the bases. So I set up my equation there. I plug in what my bases are. I add together the like terms. Now, because I have this half and I have a 7, I don't really want to do half of 7. So instead of multiplying by 1/2 through, I can on both sides just double it. So I multiply by 2. Multiplying by 2 totally does away with the 1/2 and just leaves me what was in the parentheses. So now I have twice of EF, which I can do twice of EF. I'll just distribute that multiplication of 2 into my parentheses. I get 6x plus 10 is equal to 8 plus 7x. I then subtract 6x from both sides. I subtract 8 from both sides, and I get that x is equal to 2. Once I have my x value, I need to plug it in. So EF is equal to 3 times 2 plus 5, and we find out that EF is equal to 11. In 6, I do the same process here, so I'm just going to let you look through the process. I find my x value and I plug it in to find the value of EF as 9. So now we get into discussing kites. Kites are a quadrilateral with no congruent opposite sides, but congruent consecutive sides. So you'll always have 2 pairs of consecutive sides that are congruent. If ABCD is a kite, then what we also know is drawing the diagonals will be perpendicular to each other, like BD right here to AC. And now it actually looks like a kite that you would like put a string on and fly. I'm running out of time, so I'm not going to take any time to talk about this, but here's the proof of our Theorem 59. Pause the video, come back for a quick explanation and answer to this got it. Alright, I'm going to move quickly here. We are going to start out easy and talk about angle 1 because it's at the intersection of the diagonals. It must be 90, as well as all 4 of the angles here at the intersection will all be 90. MK bisects angle K, so therefore angle 3 must also be 36. And then we need to finish out our triangle by solving for angle 2, and since we know the small angle there at the intersection is 90, I can just set up my angle sum theorem and show that angle 2 is going to equal 54 degrees. Using the similar method, please pause the video and try 7 and 8 on your own. Come back to verify your answer. Due to a lack of time, I'm just going to show your answers. Pay attention that all the diagonals bisect, so anytime you see an angle like 6 or 5, it's going to be the same as the other one given. So there are all your answers for 7 and 8. This is a really good chart to show how quadrilaterals relate to each other. If there's 2 pairs of parallel sides, we have all these options over here. If there's no parallel sides, our only option is a kite. And then if there's 1 pair, it could either be a trapezoid or an isosceles trapezoid. This is going to be the last thing we do this lesson. Try 9, 10, and 11 on your own, then come back for the explanation and to verify your answer. Alright, in number 9 here, we start easy and we say that angle 2 is 90 because it's at the intersection of the diagonals. Angle 1, you need to be a little bit more familiar with kites to figure this out, but angle 1 will be the exact same as 78 because they're in the same location in my shape. We can also prove that based off the isosceles triangle that we create on the one side. So we see angle 1 is 78 degrees, and then I solve the triangle to find angle 3, which comes out to be 12 degrees. In 10, we see that we have supplementary pairs. So 1's the supplement to 86, which would be 94, and 2's the supplement to just to angle 48, which would then be 132. And in 11, we know that the mid-segment is just going to be half the sum of the bases, so that mid-segment becomes 20. That is everything I have for your lesson today, so please, guys, let me know if you have any questions, comments, or concerns as we wrap up the last chapter of the year. We have 2 more lessons, so please make sure to keep trucking through your materials and let me know if I can do anything to help you. Thank you very much, and have a wonderful day.